Hi everyone, in this video we will continue from the last video, and in this video we will understand how to find its space complexity of a merge sort algorithm, right? And I am damn sure that nobody will teach you how they arrive to the time complexity. So I have written this in a separate page so that it looks clear. Now I have written all the calls. So basically we will start from this point, then we came to this point, then we came to this point, then this point, and then we are done with this. Then we will come to this point, then this goes like this. I am telling you why I am doing this later on. And if you have not seen the part 1, then I will recommend you to watch that part 1 so that you will understand this one, how we can drive its space complexity. And now we will number them. So this is, we will call it, this is 0th function, then this is first call, then second call. In order they will be executed. Third, this is fourth one, this is fifth one, this is sixth one, seventh, then this is eighth, ninth, this is 10th, 11th, 12th, this is 13, 14, 15, right? Now we will understand with the how this function got executed, and then we will arrive to its time complexity, sorry, space complexity. So first of all, this function will go in our stack, 0th function. Then it has three part, this then if all the three part got executed, then we will say that it completed, and we have to remove this first, but still we have to go to first. So first will come above it, now the second one, then the third one, right? Now the fourth one will not come above it, because when we are moving from third to fourth, the third one is executed, right? So that's why we will not call fourth one above it, we will remove it because it got executed, then we call fourth one. Now fourth one we will call fifth one when fourth one got executed, right? So when fourth one got executed, then we call fifth one. Now the fifth one is also got executed, so we will call sixth one. Before sixth one, since this function has three part and all the three part are done, so then we will call sixth one not above it, we will call at this position because 2 is already done. So sixth one got call in this position. Now when sixth one is done, then only we are calling seventh one. So seventh one will not come above it, it will be in the same label, seventh one. Now see, we are at this point, so we are done with the first one. So we are done with the first one. Now it's time to call the eighth one in the same level, because we are calling eighth one when first one is done. So that's why it will be in the same level. Now since 8 is not done completely, it has so many parts, so then we call ninth one above it. uh, like before calling the eighth one, seventh one is already done. Now we are at 8, now we have to call 9, right? So 9 will be called above 8 because 8 is not executed fully, so we will call the ninth. Now ninth, after 9 we have to call 10th, since it is ninth will be we have to remove ninth when all the calls are done, but 9 like 10th will be called above 9, right? And then when 10 is done, then we call 11th one. Now when 11th one is done, then we call 12th one. Now since we are at this position, 12th is done. Now we have to call the 13th one. So before 13th one, 9 is executed. Now we have to remove 9 because all the call are done of 9. So we have to remove 9. Then we will call 13. Then since we are at this position and when 13th one is done, then we will call the 14th one. When the 14th one is done, now we are at this position, right? And since when 1 is done, sorry, we are at this position and all the calls of 8 are done, so we have to remove the 8th one. Now we have to call the 15th one. Now 15th one is also done. Now we came to this point, so this indicate that 0 is also done. So see how many levels are there in the call stack? 4. So how many levels are there? 0, 1, 2, 3. If we are starting from zeros, then we call it 3 levels, right? When we are starting from 1, then there are 4 levels. So space complexity is nothing but how much is the height of the call stack. And how can we find the height of the call stack? I already told in the part 1 that it will be log n. It will be log n. How many levels are there in the tree is considered as log n, and I have already derived that part, that how it become log n. So the space complexity will be O of log n. I hope you got it. So I will recommend you to draw by yourself, and first of all watch part 1, then draw the tree, then find the time complexity, then draw this, and then do like this. Then you will understand how the recursive trees complexity, how we can find it, right? So that's all for the video. Thank you.